Problem based on triangles. First problem, the triangle ABC, D and E points on AB and AC respectively, such that DE parallel to BC if AD equals to 2.4 centimeters, AE equals to 3.2 centimeters, DE equals to 2 centimeters, and BC equals to 5 centimeters. Find BD and C, the triangle ABC, and D and E are points on triangle ABC, D, E, AB and AC respectively, and given the D parallel to BC, fine, and given AD value as 2.4 centimeters, AE value as 3.2 centimeters, DE value as 2 centimeters, and BC value as 5 centimeters, and he's asking to find BD and CE. Solution: since given that DE parallel to BC, AD by DB equals to AE by EC, that equals to DE by BC also. Since triangle ADE similar to triangle ABC, otherwise by BPT, basic proportionality theorem. Okay, now I'm taking AD by DB and DE by BC. First of all, AD by DB equals to DE by BC. AD value given as 2.4, let it be. DB value have to find, DE 2, BC 5, 2 by 5. Then cross multiplication, 2 dB equals to 2.4 into 5, then dB equals to 2.4 into 5 divided by 2, 2 ones, 2 1.2, so 1.2 into 5 gives 6, therefore dB value is 6 centimeters. Now apply this, AD by dB equals to again AE by EC. AD value 2.4, dB value 6, AE value 3.2, EC we have to find. So by cross multiplication, 2.4 EC equals to 3.2 into 6, then EC equals to 3.2 into 6 by 2.4. Now 0.83s, 0.84s, 3 ones, 3 twos, that equals to 8 centimeters. Therefore EC value is, or CE value is 8 centimeters. Going for the next problem. In a triangle ABC, P and Q are points on the sides AB and AC respectively, such that PQ parallel to BC, PQ parallel to BC, PQ parallel to BC, if AP equals to 2.4 centimeters, AQ equals to 2 centimeters, QC equals to 3 centimeters, and BC equals to 6 centimeters. Fine. AB and PQ. Now, given information, ABC is a triangle, P and Q are points on AB and AC respectively, and given AP value 2.4 centimeters, AQ value 2 centimeters, QC value 3 centimeters, BC value 6 centimeters. Now we have to find PQ length and AB length. So first solution, given PQ parallel to BC, since PQ is parallel to BC, AP by PB equals to AQ by QC by basic proportionality theorem by PPT. Now AP value is 2.4 by PB equals to AQ 2 by 3, cross multiplication, 2 into PB equals to 2.4 into 3, then PB equals to 2.4 into 3 by 2, 2 ones, 2 1.2s, then PB value is 1.23 is 3.6 centimeters. Now get the value of AB. AB equals to, from figure, AP plus PB, right here 3.6 centimeters. The AP is 2.4 and PB is 3.6. Total sum up to 6 centimeters. Total sum up to 6 centimeters. Now we have to find the PQ, and AP by, see here, this angle are equal because parallel, corresponding angle, this angle are equal. This, so by angle property, triangle consider triangle ABC and triangle APQ. Angle APQ equals to angle ABC, corresponding angles. Angle A is common, therefore triangle ABC is similar to triangle APQ. So when two triangles are similar, corresponding sides are in proportion. That means AB, so if I am taking first one, AP by AB is equals to PQ by BC. To substitute in the values, AB value 2.4, AB value normally found 6, by PQ by BC value 6. Now these two will cancel, then PQ value get up to 2.4 centimeters. Therefore PQ value equals to 2.4 centimeters. Going for the next problem. If D and E are points on side sides AB and AC respectively of triangle ABC such that DE parallel to BC and BD equals to CE. Now prove that ABC is an isosceles triangle. Given that ABC is a triangle, D is a point on AB, E is point on AC respectively. Given this is parallel to this, and BD equals to CE given, we have to prove that ABC is triangle. That means in triangle ABC, DE parallel to BC, so I can write AD by DB equals to AE by EC by basic proportionality theorem. Now also given DB equals to or BD equals to CE, DB equals to CE. That means the place of DB I can write EC or CE. So AD by EC equals to let it be 1 AE by EC from 1. Now this to be cancelled. Therefore AD equals to AE. AB equals to let it be 2 AD plus BD. AD equals to AE, BD or DB equals to CE from 1 and 2. Now AE plus EC equals nothing but AC. That means AB equals to AC. Two sides are equal. It is isosceles triangle. Therefore, triangle ABC is an isosceles. Problems based on triangles part 2. First question. In figure, A comma B and C are points on OP comma OQ and OR respectively such that AB parallel to PQ and BC parallel to QR show that AC parallel to PR. Let me get the figure first. PQR is a triangle. O is intersection of P, O, OQ and OR. Now A is the point on PO, B is the point on OQ, C is the point on. Now again BC parallel to QR, yes. AC parallel to PR. Now we have to prove, we have to prove AC parallel to PR. That means he given BC parallel to QR and AB parallel to PQ. AB parallel to PQ. Okay. Solution. In triangle OPQ, AB parallel to PQ. That means OA by AP equals to OB by BQ by BBT. Equation 1. Now in triangle OQR OQR, OB by BQ equals to OC by CR, same by PBT only, equation 2. Now substitute equation 2 in 1, we'll get OA by AP equals to, in the place of OB by BQ I'm writing OC by CR. If you observe, OA by AP equals to OC by CR. Therefore, in triangle OPR, AC parallel to PR by converse BPT. So these two are also parallel now, have to be proved. And for the next problem, in figure DE parallel to, if DE parallel to AQ and DF parallel to AR, prove that EF parallel to QR. Now get the figure first. PQR triangle, it is A, DEF. Solution, in triangle PQA we have DE parallel to AQ, that means these two are parallel. Triangle PAQ or PQA, we have DE parallel to AQ, so you can write PE by EQ equals to PD by DA, PD by DA. Now in triangle PAR, we have DF parallel to AR, DF parallel to AR, DF parallel to AR. Again I can write here PF by FR equals to PD by DA. Let be equation 1, let be 2. Now 1 equals to 2, because RHS equal, LHS must be equal. I am equating the LHS now. P by EQ equals to PF by FR. Observe that PE by EQ equals to PF by FR. In triangle PQR, now EF is parallel to QR. That's what we have to prove by converse BPT, because triangle PQR, PE by EQ equals to PF by FR, sides are in proportion. That means these two lines should be parallel by converse BPT theorem. Going for the next problem, third one. In triangle ABC is a triangle ABC AB equals to AC, points D and ER on the sides, AB and AC respectively, such that AD equals to A. Show that points BCE and D are concyclic. Solution. I get the figure. A, B, C and D and E are points on A, B and AC respectively. That means we have to show that B, C, E, D are concyclic. That means if we draw a circle which passes this through this 4 points should be on same circle. That means this should be the cyclic quadrilateral. So here we have to prove that BCED is cyclic quadrilateral. That means angle B plus angle E equals to 180 and angle C plus angle D, that means angle BDE. Here also write angle B plus angle DEC or CED equals to 100 because opposite angles are supplementary in cyclic quadrilateral. Now solution. Given that AD equals to AE, given that AD equals to AB equals to AC and also AD equals to AE. Solution. In triangle ABC we have AB equals to AC and also AD equals to AE. That means these two sides are equal, AB equal to AC and AD equal to AC. Obviously BD equals to EC also. BD equals to AC. BD equals to AC. Now we have write the ratio AD by DB, that equals to, in the place of AD I can write AE, in the place of DB I can write EC. So that means AD by DB equals to AE by EC. Some given we got. So DE parallel to BC by BPT. DE parallel to BC by BPT. Therefore angle D equals angle ADE equals to angle B, corresponding angles. Okay, now angle B plus angle EDB equals to 180 because angles on same side of transversal, internal angles on same side of transversal. Now angle B plus angle EDB equals to 180. Now he given AD equal to EC, that means this angle must be equals to this angle. So in the place of ADE I am writing AED. So in the place of B I am writing, that means ADB equals to B. So replacing with ADE plus EDB equals to 180. Now in the place of ADE I am writing AED, angle AED plus angle EDB equals to 180. Angle AED plus angle EDB equals to 180. Now angle AED plus angle DEC also 180, linear pair. Here angle ADE equals to angle AED, linear pair, this one. Now from these two equations, this angle is equal, obviously this angle must be equals. So from 1 and 2, angle EDB equals to angle DEC. This angle EDB equals to angle DEC. Okay, now in the place of AED, again I am writing angle B, because angle AED equals to ADE, angle AD equals to B, angle B plus angle D is equals to 180. So which we have to prove? Opposite angles sum up to 180. If these two are 180, obviously these two must be 180, because sum of the quadrilateral should be 360. Two angles sum up to 180, so remaining angles must be sum up to 180. Therefore angle C plus angle BD is also equals to 180, hence prove. Problems based on triangles. First question. D is midpoint of side BC of a triangle ABC. AD is bisector at the point E. And BE produced cuts AC at the point X. Prove that BE is to EX equals to 3:1. ABC is triangle. D is midpoint of BC, and E is point which bisects the AD, and B is extended to X, BX, which intersects AC. Solution given. D is midpoint of BC, and E is midpoint of AD. So draw now DF parallel to BX. So DF parallel to BX. Now consider triangle BCX, BX equals to 2DF by midpoint theorem. Why so? If you observe carefully, D is midpoint of BC. A line drawn parallel to it from midpoint, it intersects the XY at midpoint, or the line drawn from the midpoint of one side parallel to the second side bisects the third side, and moreover it is half of the parallel side. That's what we did. DF is equal to half BX, bring to this side, BX equal to 2DF. Let be equation 1. Now consider triangle ADF. Consider triangle ADF. If BX is parallel to DF, EX is also parallel to DF. So again, E is the midpoint of AD as given. Again we can write DF equals to 2ex. Same by midpoint theorem. It will be 2. Now substitute 2 in 1. You'll get bx equals to 2 into 2ex. That means bx equals to 4ex. I can write bx as split the bx, be plus ex, that equals to 4ex. So be equals to 4ex minus ex. That means be equals to 3ex. Bring ex this side. be by ex equals to 3:1. What he has to prove? B is to x equals to 3:1. Hence proved. Go for the next problem. In figure, we have AB parallel to CD parallel to EF. If AB equals to 6 centimeters, CD equals to x centimeters, EF equals to 10 centimeters, BD equals to 4 centimeters, and DE equals to y centimeters. Find x and y. Find x and y. Now given AB parallel to CD parallel to EF, so all these are parallel. Now he given the values AB 6, CD x, and this is 10, and AC so BD he given BD 4, and so this is A, that this is B, C, D. Okay, make corrections. AB, CD, EF. So 6x 10 as given, BD 4 centimeters, DE y centimeters. We have to find x and y. Solution: consider triangle CDE and triangle ABE, or ABE. Both triangles are similar because common angle here. If you consider CDE, angle E is common in angle triangle ABE also, and these two are parallel. These two angles are equal corresponding, and these two angles are equal corresponding. So by AA criterion, triangle CD is similar to triangle AB. By AA criterion, so I can write DE by BE equals to DE by BE equals to x by 6. DE by BE equals to x by 6. That means y by y plus 4 equals to x by 6. Now
let it be 1. Consider triangle ABE. This is line drawn parallel. By BPT we can write 4 by y, 4 plus y, 4 by 4 plus y, that means AC by AC by AC by AE. AC by AE. Let it be 2. Now consider triangle ACD and triangle AEF. I can write AC by small triangle, because these two triangles are similar by same criterion, because CD parallel to EF. So can write AC by AE equals to x by 10. AC by AE equals to x by 10. Now if you observe this triangle AC by, and here itself we can write AC by AE equals to BD by DE by, so CE by, in this triangle ABE I can write CE by AE equals to CE by AE equals to, or I can write here again. Consider triangle ABE. I can write CE by AE equals to DE by BE, that equals to, which is x by 6 from 1. Observe this, DE by BE equal x by 6, that means CE by AE also x by 6. Now this is 3, this is 4. Now from 3 I can write AC by AE equals to x by 10. From 3 I can write this as AE minus CE by AE equals to x by 10. Now AE, split this, AE by AE equals to CE by AE, that equals to x by 10. That means 1 minus CE by AE is nothing but x by 6 from this, x by 6 equals to x by 10. Now solve this properly. Take LCM. 6 minus x by 6 equals to x by 10. 2 5s, 2 3s, cross multiplication. 30 minus 5x equals to 3x. Bring minus 5x this side, you will get 8x equals to 30. Then x equals to 30 by 8. 4 15, that means x equals to 15 by 4. Let it be 5. substitute 5 here, 5 in 1. So y plus y by y plus 4 equals to y by y plus 4 equals to x by 6. 6y equals to x into y plus 4. On substituting, you will get 6y equals to 15 by 4 into y plus 4. Cross multiplication, 24y equals to 15y plus 16. Bring 15y this side, you will get 24 minus 15y equals to 60. 9y equals to 60. Then y equals to 60 by 9. 3 20s, 3 3s. Therefore y equals to 20 by 3 centimeters. Finished. Problem based on triangles, part 4. First question. In figure, angle A equals to angle CED. Prove that triangle CAB similar to triangle CED. Also find value of x. So find value of x. No. From figure, ABC, this is 7 centimeters, this is 8 centimeters, and this is 10 centimeters, this is 2 centimeters, and this is x centimeters. Okay, and this is given as 9 centimeters. Angle A equals to angle CED, it seems. Okay, these two angles are equal, given these two angles are equal. Solution. In figure, given that angle A equals to angle CED, no, let it be 1. Consider triangle ABC and triangle CDE now. Triangle ABC, angle A is equals to angle CED given from 1. Angle C is common, therefore can write triangle CAB similar to triangle CED, similar to triangle CED. Now, since these two triangles are similar, CA by CA, which is opposite to B, this, so here this is a common angle, so obviously this angle and this angle are equal. So I'm writing AC CA, which is opposite to angle B, So similarly, this opposite to this CE. CA by CE equals to DE. Here taking the CA, side in the big triangle, then after CE, side in the small triangle. So corresponding sides. Now I need to find DE, but I wrote here in denominator for small triangle. So here also DE in the denominator, because big triangle by small triangle, big triangle by small triangle. We have to maintain the ratio properly. So which is opposite to C, and again which is opposite to C is AB. Now CA, 7 plus 8 15, CE 10 is equals to AB 9 by X. 5 2s, 5 3s, 3 1s, 3 3s. By cross multiplication we'll get X equals to 6 centimeters. Finished. Next problem. Question number 2. In figure, PA, comma, QB and RC are perpendiculars to AC. Prove that 1 by x plus 1 by y equals to 1 by z. Solution. So let me get the figure. A, P is length x, QB length y, RC length z. Given that PA perpendicular to AC, QB perpendicular to AC, RC perpendicular to AC, means all these angles are 90. Now consider triangle CPA and triangle CQB. CPA and CQB. Angle CBQ equals to angle CAP 90 degrees perpendicular, so it is 90. Angle C is common here, angle C, or angle PCA equals to angle QCB, common angle both. Therefore triangle CPA is similar to triangle CQB. Therefore I can write corresponding sides are in proportion. So I'm taking y here, small triangle, by x in the big triangle, because opposite corresponding sides, sides opposite to same angle. Now here these two angles are same, so this must be equals to, first I write the small one. Left side I choose smaller triangle in the denominator. Here also I have to choose smaller triangle BC by AC. Let it be 1. Consider triangle ACR and triangle ABQ. Again angle ACR equals to angle ABQ 90 because perpendicular 90, and angle RAC equals to angle QAB, common angle. So this is by AA criterion. Here also triangle ACR similar to triangle ABQ by AA criterion. Now again I can write y by z, small y, side of QB opposite to this angle, by, so in big triangle also we have to take the side opposite to same angle Z equals to AB, which is opposite to this one. This angle is equal to this angle because both are similar. These two angles are equal. This is common angle. Remaining angle is this two. These two also equal. Now opposite to this two is this angle Q is AB, and these two are equal. In big triangle we have to take this side opposite to this angle, that is AC. Equation 2. Add 1 and 2. You'll get y by x plus y by z equals to BC by AC plus AB by AC. Then you'll get, take y common, 1 by x plus 1 by z equals to AC common here, I can add BC plus AB. So y into 1 by x plus 1 by z equals to AC by AC, because BC plus AB is nothing but AC, that is equal to 1. Now 1 by x plus 1 by z equals to, bring y to right side, will get 1 by y. Hence proved what he asked. Going for the next question. In figure, triangle ABC is right angle at C, DE perpendicular to AB. Prove that ABC is similar to triangle ADE. Okay. Also find AE and DE. Let me get the triangle first. A, B, C, right angle here, and he given DE perpendicular to AB, that means this is also 90, and this is 3 centimeters, 2 centimeters, 12 centimeters. Solution. Consider triangle ABC, triangle ADE, angle C equals to angle AED, that equals to 90, because this is right angle triangle given, right angle at C given, and DE perpendicular to AD means this angle is 90 from given. Angle A is common in both. Yes, therefore triangle ABC is similar to triangle ADE by angle criterion. Now we need to find DE. So first concentrate on DE, which is opposite to angle A. So DE by BC is equals to DE by BC is equals to, so this is the angle here and this angle are equal. You'll get AE by AC, AE by AC. Now this is equation 1. Now consider AC is 9, DE by BC value is 12, that equals to AD, AD, you know, AE. So AE by AC. AC is nothing but 5. So let it be like this. we asked to find DE. Again we can write DE by AD. DE by DE opposite to A. DE by AD is equals to BC by AB. From this we can get DE. AD value is 3. AD value is 3. BC value, if you observe ABC is right angle triangle, this is 5, this is 12. Obviously this should be 13 centimeters. Total is 5. Triplet. AB square equals to BC square plus AC square. 5 square plus 12. That means 25 plus 12, 144 plus 25, 169. Root 169, 13. So length of AB is 13. So length of AB is 13. So BC 12 by 13. Then you will get DE value as 36 by 13. Now substitute this value, equation 3, that will be equation 2. Equation 3 in equation 2 we will get 36 by 12 into 13 is equals to AE by 5. 12 ones, 12 threes. On cross multiplication you will get 13 AE equals to 15. Then AE equals to 15 by 13. Finished.